Let me give you an alternative proof to the compensated law of demand that relies on a more geometric intuition for these results. Let me first develop this expression here. This is the compensated law of demand. I'm going to multiply everything on the right hand side here by p prime first and then by negative p. So I get p prime times x p prime w prime minus p prime x pw minus px p prime w prime, and then the two negative signs cancel out, plus px pw, and I have to show that this entire expression here is non-positive. Let me show what the budget sets look like. So first I have prices P. Here's a budget set, and I pick X, PW. Then prices change to P prime. And there is a compensated price change, so the original bundle remains affordable. Here is P prime, and I'm picking second bundle X P prime W prime. So both X, the first bundle, and the second bundle are on the efficient frontier at prices P prime, and the fact that they are both on the efficient frontier means that by definition P prime times the original bundle is equal to some constant, and P prime times the new bundle is also equal to some constant. So these two items here on the expression are equal, right? They're equal to some constant, so they cancel out. So this entire expression here, this is equal to 0. Now if I look at the original budget set, which I'm going to draw here, by definition every item here that is located on this region is such that Px is less than or equal to some constant. Not necessarily the same constant as here, right? It could be a different number, but I'm just going to use C to make this simple. Every item located directly on the efficient frontier is such that Px is equal to some constant, and every item located on the right, let me change color, every item located on this hyperplane, drawn in blue, is such that Px is greater than or equal to some constant, right? So the budget line here separates the plane into two hyperplanes, and you can define every point in the space will either be such that Px is less than or equal to some constant, or such that Px will be strictly equal to some constant, or on the right side of the plane, you'll be greater than or equal to some constant. So the original bundle, X, is on the efficient frontier. So for X, for the original bundle, we have Px is equal to C. For the second bundle, the second bundle is revealed preferred to the first bundle. Why? Because it's picked when the first bundle is available at P prime. So in order for warp to not be violated, when X is chosen, the second bundle X P prime W prime must not have been available. So the second bundle must fall outside of the original budget set. So it must be in the blue region. So we must have P x P prime, W prime greater than or equal to C. It must have been unaffordable. And from these two equations that I've just written out, you can see that if you go back here, you can see that this will be negative or equal to 0, since this here is equal to C, and this is greater than or equal to C. And so you've just shown that the entire expression is non-positive, just relying on this intuitive geometric proof.